Hey everybody, my name is Jeff Heiking. I am a professor at Purdue University, part of the Purdue Polytechnic here in Anderson, Indiana. And today I'm going to spend a little bit of time talking about 3D printing. 3D printing is one of a few different types of methods, usually referred to as additive manufacturing. And additive manufacturing is a section of manufacturing that's different from traditional or subtractive manufacturing, in that with subtractive you start with the raw material and you use a tool to take away that material. With additive manufacturing, typically you're taking one layer, adding it onto the previous layer, and building up that three-dimensional object. One of the major benefits of additive or 3D printing is that you can create much more complex shapes using an additive process than you can with subtractive. You know, try to envision creating a hollow sphere using subtractive manufacturing. How do you get the material out of the inside? You'd have to have two different parts to put together. In additive, you can actually just build one layer onto the other and create a solid object that is hollow. And it can get much more complex than that. Additive manufacturing and 3D printing are becoming much more common in manufacturing and in many different industries. According to 3dprinting.com, adoption of 3D printing is commonplace among many industries, as those who have yet to integrate additive manufacturing somewhere in their supply chain are now part of an ever-shrinking minority. So what we're seeing is more and more additive manufacturing, and specifically 3D printing, is becoming part of industry and modern manufacturing technologies. These manufacturing processes are typically broken into two different groups. There's rapid prototyping and then rapid manufacturing. Rapid prototyping is just the process of making a test model for whatever part or device that you have designed. In the traditional methods using subtractive, you'd have to actually purchase and use the actual material or a test type material that you would use in the real part and manufacture it from that perspective. Using rapid prototyping, we can use plastics or polymers that are less expensive, and in many cases either recyclable or reusable, and create the prototype to do the testing to make sure it's the right size, it's the right shape, it fits what it's supposed to do, perhaps even in some cases has some of the right properties. So with the addition of additive manufacturing or 3D printing, typically that makes that process less expensive and a little bit faster. In the case of rapid manufacturing, now you're actually using these additive techniques to manufacture the pieces and parts that you intend to use as part of your actual device. For example, there's an engine manufacturing company here in Indiana. About 10% of the parts of their engine are actually 3D printed. They're metal 3D printed, but they are still 3D printed rather than using traditional subtractive techniques. And so we're starting to see that more and more. Plus, as plastics and polymers continue to grow in popularity, we're going to see 3D printing and additive manufacturing become more and more prevalent in those industries where they can do that instead of injection molding or things like that. Now, the drawback is typically additive manufacturing is used for short runs or small batches in a production. You're not going to produce 100,000 of these parts necessarily a week, or 10,000 parts a week or something like that using additive manufacturing, because it's just not that fast. So this is a fused deposition modeling printer. It's a MakerBot is the manufacturer. And what you can see it doing is it's laying down one layer at a time on the previous layers. And in this case, what it's building is this chain. So it actually printed it so that the rings were separated from one another, but only touching the base. So that's how it was able to be printed as an assembled model. You break it away from the base, and now it can move just like a chain. If I wanted to make a longer chain, I would just have to duplicate this over and over again and stretch it further out, and I can make a longer chain. But you can see it laying one layer on top of another as it's building up that model. So a little bit about some of the types of 3D printing. Most people, when they think of 3D printing, what they're really thinking about is called fused deposition modeling. That's where you take a polymer material, you heat it up to a point where it flows, and you actually extrude it out almost like cooked spaghetti, and you lay it down on a bed. And you create one layer, and then the printer head goes up a little bit and puts the next layer on top. And it's fusing the deposited layers from one to the next, hence fused deposition modeling. That's what most people think of when they think of 3D printers, because those are the most commonly available, the least expensive. You can go online and you can buy kits to build yourself for a couple $100, and you can be 3D printing in your own home. All the way up to spending well over $100,000 on a more advanced model of that same technique. Another common methodology is stereolithography, also sometimes referred to as SLA. In that case, we start with a liquid polymer, and we expose that polymer to an ultraviolet light. That ultraviolet light turns that liquid into a solid by curing the polymer. These are fairly common in some industries, and they provide with a different level of detail that you can get from the fused deposition modeling, or FDM. Dentistry is one common use for this SLA type. You can actually, they have a polymer that when exposed to the ultraviolet light can turn into a replacement tooth or a crown. They can actually 3D print those in the dentist's office, and those are actually fairly commonly used. The process is the same. The ultraviolet light is shined on that material, it solidifies it, and then it puts another layer of the liquid on top and solidifies it, and kind of builds it up from one to the next. The difference, one of the biggest differences between the materials that are used in that fused deposition modeling and the stereolithography is with the FDM, it can usually be reused or recycled, whereas with the SLA, it is not. It's a one and done. Once it's made, and you're not going to reuse it. The other major impact to 3D printing and its use is the addition of support material. I talked about how you can create much more complex shapes. Well, in 3D printing, if I'm building one layer on top of another, I have to have something underneath to put the next layer on top of. So if the shape is fairly simple, then whatever the bottom layer is just continues to build up. But say I want to build up and I want to go off to the side, I have to either have something below to hold on to it, or like cooked spaghetti, if I try to hold it out straight, it's not going to. It's not going to suspend itself in the air. So I have to have something underneath. So many of the inexpensive 3D printers, you would have to use that base model material to create a structure underneath as support to build out that piece of your device. Some printers use a soluble support material. Typically soluble in either hot water or a hot chemical solution that's non-toxic and safe for the environment. After the printer finishes what it's doing, you put that into this solution or this hot water bath, let it sit for a little bit, and it dissolves that support material, so to the point where you could actually create two chain links not touching one another and 3D print them so that they would be two links that would maneuver, or you could print an assembly that could move. We saw a little portion of a small version of an engine that rotates. That was 3D printed as one piece, but you could actually turn it and rotate it, and the parts would rotate within each other without having to be assembled, because it was printed in its assembled positions. So last thing I want to kind of talk about a little bit, or the next thing I want to talk about really, is where you see these. Talked a little bit about how you can see some of this in dentistry, in general manufacturing. You're going to see 3D printed parts in many consumer products, footwear, eyewear, furniture, some industrial products. I mentioned dental prosthetics is another big use for 3D printing. Some of them plastic, some of them metal. There are prosthetic hands and arms that are 3D printed. Feet and lower parts of legs can be 3D printed. That we actually talked to somebody in the 3D printing industry, and a doctor took a scan of somebody's heart, had them 3D print the heart so he could decide how to best to go in and repair the damage to the heart before he even went in and started the surgery. That can reduce surgery time, it's less invasive, better for the patient. The doctor already had his plan going in, and so you're seeing it in those industries as well. So the printers we have here are inexpensive printers that you can buy online for a couple $100s. They come as a kit. The assembly is pretty straightforward. Took about 30-45 minutes or so for me to put it together. It does not require a degree in engineering. It's pretty straightforward to put together. And the instructions for using them are pretty straightforward. So this is a fairly inexpensive way to kind of get yourself into 3D printing. These particular models here were used by some of our freshman students as part of one of their introductory classes. We were able to talk about a variety of different engineering concepts, gears and motors, things like that, as part of the assembly and function of the printers. And then we actually had them do some design, a design challenge, as it were, to come up with something to improve these. And you can see a couple of these things on this particular printer here, where they added a holder to guide the filament in. And so the students were not only learning about 3D printing, but they were learning how to design as engineering technologists to prepare themselves for careers in those areas. A couple of future careers that you might not necessarily think of. A chef using 3D printers to print actual edible food. Chocolate has been done, pizza has been done, and you're starting to see a few more industries where they're using a version of 3D printing to kind of create their food. We talked about prosthetics. That's another really big one there. Art is another one where 3D printing is commonly used. We have a gentleman that's helped us out with some of our 3D printing labs. He's an artist, and he actually 3D prints characters that he includes in his graphic novels and paints them, so he has an actual physical model of the character that he's put on paper or on the page. And then the last thing really just to touch on is education. So you want to become someone you want to work in an industry that's involved in additive manufacturing. What do you do? Most of those industries are looking for people who have some technical knowledge, either in the design area, in engineering or engineering technology, computer science, things like that are common college tracks to take if you want to be involved in additive manufacturing or 3D printing. According to 3D printing market size and share, the global 3D printing market is expected to grow at a compound annual growth rate of 14.6% from 2020 to 2027 to reach 35.38 billion by 2027. So obviously that's a high growth industry. If it's growing at almost 15% per year, that's huge. So now is the time to get involved in it, get invested, and learn how to become part of that process. So that's all I've got for today. Thank you very much. Appreciate your time.